This video will be a continuation of a tutorial on Simulink data type propagation engine. In particular, this will be focusing on propagation time when a block receives a proposal from Simulink engine, and the first step that the block needs to do is to decide, will it accept that data type or will it throw an error? Bring up a model. Okay, now in this model we have two pairs of blocks. This block is a master. We looked at this in the previous video where at initialization time, the initialization phase of propagation, this block came along and said, my input port will be a single. This is the S-fun in single, and there's also an S-fun out single. Let's make sure we have that one available to look at quickly. That one is also saying to set its output port to be single. Okay, if we go back to the model, so this one is saying that this signal on its output must have data type single, and this one block here is saying its input must have data type single. What's new in this video, we'll be talking about these blocks, which are initially passive. They will initially come and say, during the initialization phase, they say, I don't know what the data type is yet. Okay, and this other one is saying the same thing, except in the other direction. Its input port, it's saying, I don't know what the data type is yet either. So let's go ahead and begin to analyze this model, what we're looking at. And if we go to this workspace, similar to what we did last time, we can look at this model and we can pretend to be, through recording information of the structure, to be like Simulink engine and keep track of what's happening. So at the initialization phase, we'll have two singles set and the other ones will be passive. To help understand this better, I'm going to use a C++ debugger. In this case, I'm on Windows and I'm using Visual Studio. So what I'll do here is I'll tell it that I want to attach to the MATLAB process. So there we have MATLAB. We'll attach to that. And then also let's go and let's bring those files into Visual Studio so I can set breakpoints. So let's open Files, and if we go to this directory, let's see, it's sorted by type, which I believe is what I want. Okay, let's go ahead and just grab all this C++ code. Let's open those up, and in particular, we want to find this one here, which I showed you previously. This one is setting up in the initialization phase. It says its data type is dynamically typed. And then we're having a new method where Simulink engine will call this function when another block has proposed a data type. So this will happen in the second part of propagation. First there's initialization phase, and then after every block has done what initialization it can, there begins a propagation phase where Simulink will give information to an individual block. So let's set a breakpoint in this function, and let's grab the other one that's going in the other direction. And in this case, we have that it's proposing, actually let's set the breakpoint here. Okay. So now let's go ahead and begin to update diagram on this. Okay, and that now we've hit the breakpoint. And let's go back for a minute and see if, oh, we're not able to use MATLAB at this point. Okay, so we'll just use the C++ debugger and go through what we're seeing. So what's happened is we've come into this function, and the engine says someone else connected to your signal, and we know it's an input because of the function it called. And then we also have the port index, and the port index is 0, so this is the first input port. Someone else has proposed that that have data type ID of value 1. I happen to know that that value 1 corresponds to this value of being a single. So here's where we have the chance for the block to accept or reject this data type. So in this code, it's looking at the data type and saying, oh, okay, are you an int 8 or a single? If you are, then I will accept you. So if not, we'll throw this error shown here on line 46. So it was one of those types, so it was okay. So we're going to accept it. And so the block then goes and sets its input port data type to say, I've accepted your proposal. And for this simple block, we're all done. We're all done. We've just accepted. That's all we're doing in this simple example. Now this is the other block that had an output port. So the output port, we know from the function it's called, and then the port index is 0, so it's the first output port. And again, it's been proposed that it be data type ID 1, which again is single. So we check that, which is something this block can handle. And then again, we accept that and set the output port data type to that. And then we can continue on our way. And everything should be good. So if we come back here, we can see some of the printouts that happened. So we can work our way through this in a moment. Okay, so let's go back and look at what happened with this and try to mark down what's happening, like pretending to be Simulink engine. So again, we see initialization phase here, and also here and here. So all 4 blocks got called in the initialization phase, and B1 said, I'm a master of my output data type, and I demand that it be single precision floating point. The next block, B2, came and said, my input port is inherited, so I'll leave that as an empty matrix to represent that. Then B3 came and said, oh yeah, I'm just inherited. Again, we'll leave that empty. And then finally, B4 executed, and it said, I want my input port to be single. I demand that it be single. So we can enter that. Now at this point, all the blocks have done their initialization. Now it's up to Simulink engine to propagate that information across blocks. And so it's next going to block B2, and block B2, which is part of signal B that we've marked here. And so it was known that this was single, and then it propagates that information to this block. As we saw in the debugger, it came in and says, hey, it's been proposed that your input port 0 have data type single. The block looked at it and said, yes, that's fine, I accept that, and then it was done. So that one ended up in a happy situation where everybody agreed that signal B was to be single. And then the same thing happened with block B3. The engine came and said, hey, it's been proposed that your output port 0 have data type single. The block looked at it and said, hey, I'm happy with that. And so everybody was happy. There's no errors, and update diagram reached a nice place. Okay, now we're going to look at another example where in this case this block is a master saying its data type must be double, and this one is also a master saying its input must be a double, and that's connected to these other blocks which were initially passive. So let's go pretend to be Simulink engine again, and we'll find B4, and B4 says must be a double, and then I believe it's B1 says the same thing, and so initialization phase will know it's a double, and then propagation will propose double to these other blocks. So let's go ahead and see how that goes. Again, we've come into the C++ debugger. It's the input port for this block is input port 0 is proposed to have data type 0, which happens to correspond to double. And so now when we come to this test will fail and will set an error and continue, and that's the end of simulation. Data type propagation didn't even bother to go to the next block because it was all over. We had failed. We got a disagreement here. So this block errored out saying that it can't accept that data type, and the error tells us that that data type came from this block. So that shows the basic propagation time activity of a block that initially said its data type was dynamic or inherited. And it would come into the code and it can decide, do I accept it or do I throw an error? And so that's what these demos have shown, both cases of one happily accepting the data type that's proposed or throwing an error. Thank you.